Ciao Bui-san. Bonjour. Dzień dobry. Guten Morgen. Bonjour. Buongiorno. And Ohayo gozaimasu to everyone. Good morning. Today's video really marks a transition in the Zoomtown experiment. We've been going at this, I think this is technically week 43 now. 42nd episode went out last week. And this phase of the experiment, I'm calling it phase 3, is going to be a transition from primarily focused on the development of the Zoomy and its control software to now where we're going to be looking at the entire system. Still a lot more development to go, but it's not going to be focused just around the Zoomy. There's much more to the Zoomtown experiment than just the Zoomy. Now, from the beginning, I made it clear that the focus is the Zoomy because it is working around the PICO and Micropython. Now, we'll be talking about some of the other software, and I will have some questions for you a little later in the video, and I need your feedback to guide me on what you want to see. But first, before we get into all the details, let's go over what I want to cover today, and then we can move forward over to the Zoomtown. At this point, Phase 3 has begun. Phase 3 will consist of integrating everything together as a system as opposed to individual components. So based on that, we're nearing the end of the Zoomy control software development. We still have more work, not much. We're ramping up the scheduler software development, and the scheduler has changed in functionality substantially from when I first started coding it almost a year ago. Implementing integration of all the components. That's going to be a little bit more understandable here in a moment. Testing is becoming much more time consuming. Oh my goodness. That's the part that's really slowing this down, but as you can imagine, as I'm integrating all of this, everything imaginable has to be thought of and tested. And if you make changes, you got to go through and repeat all of those tests again. So this is where things are going to get challenging. The presentation format is going to change. Now, historically, this has really been mostly about Micropython programming and very focused on that. But now we have to almost take a step back and take a top-level view of everything that's going on. So less of the details, more of an overview and updates as to how things are progressing. I hope to still attempt to try to keep these under 20 minutes, and I know I fail miserably at that. But I'll try to keep them as concise as possible. I will be needing your opinions and thoughts on a few things as we progress through today's video, and I may need some volunteers, and that will make a little bit more sense in a few minutes, and then once you see me demonstrate what it is that I think I need help with. So with that, let's just go into a sort of a review of the overall Zoomtown experiment, and then we can get over there. Zoomtown, the experiment, consists of 16 Zoomies, robotic cars that are controlled by PICOWs. There's one scheduler, which is the system controller of the entire experiment once we get to that phase. And that is built around a Raspberry Pi 4 with a Pygame add-on module to help with all the graphics and the user interface. There is an MQTT broker running on a separate Raspberry Pi 3, and that just literally sits here in my shop and runs all the time. Now, as you can tell, MQTT is the messaging service that we will be using to communicate between the scheduler and each of the zoomies. All of that runs through a Wi-Fi hotspot here in the shop, and that is the primary means or methodology of communication I have for everything here within the shop. And finally, all of this plays out on the city layout we've been calling Zoomtown, and that consists of 32 parking spaces with 22 roads. Here's an overview of what Zoomtown is like from the logic point of view, or the communications between the different devices. At the core of everything is the MQTT broker, and that takes in all the messages and routes them to the correct Zoomie, etc. So it's a message broker. And frankly, it just runs all by itself, and you almost never interact with it at all. It's just a piece of software running on a Raspberry Pi, and monitors all the messaging. Around everything are the 16 Zoomies, each with its own unique identification, starting with Z and ending with either a number or a letter. And that gives it a very unique identification. And as we've shown, let me grab one real quick. And as I've shown in previous videos, this is the top of the Zoomie, and that's its identification tag. Now, I had mentioned a few weeks ago that we were thinking about using a vision system-based global positioning system to track the locations of these. And that's why I've made them so large and clearly identifiable, so that the vision system could pick them up. I don't think we're going to need to go that way, but that's something we'll learn once we get into experimentation. So each Zoomie has to communicate to the Zoomtown scheduler, and the Zoomie is passing information about its location and some other little details so that the scheduler knows where the Zoomie is and what it's doing. The scheduler also communicates to each of the Zoomies, essentially start and stop information from our manual controls on the scheduler's operator panel. It also communicates to each Zoomie its driving instructions to get from point A to point B for each of its trips. Think of it as the navigation system in your car. You put in your destination, and it will give you the driving instructions from point A to point B. There is also some other communications going on between the scheduler and, of course, each of the Zoomies, and we'll dive into that in more detail when the time is right. Now, within the scheduler, we had talked a while back, I really wanted to use one of the shortest trip graphing algorithms that's used for plotting out the shortest distance between point A and point B in graphing, or in our case, navigation. And there's many of them, and they're all very good, and they're kind of fun to use, but the more I thought about it, it was realized that that is actually going to present a problem rather than a more natural test environment. The problem being everything's going the shortest route, so everything has to go through city center, which really isn't how people would drive in the real world. We would often take highways or primary roads to go around city center, and then that way your trip is more efficient and less congested through the less congested area. So I had to come up with a way to program, for a human, to program these paths. And that's a little more complicated than you can imagine. But what I did, I figured the best place to do that's incorporate it within the scheduler, this programming ability to be able to select a start destination and an end destination and which roads to use to get there. And then let it figure out, and the Zoomie figure out, all the little details apart from destinations and the roads to use. And that's what I'm showing on this graph here. the programmer would select the roads indicated by the red lines there with the arrowheads. And then when the scheduler calls up a trip plan, it will say, okay, I want to go from this point to this point, and communicate that to, in this case, Zoomy Z, and give it those same exact order of roads and destinations with additional information mapped in, like the turns and areas where you need to pull forward a little bit when you enter an intersection and all that. Little bits of data like that that isn't necessarily part of your basic road mapping system. So that's what you see here. And then we get to this one here. And this is, as you can tell, this is the graphic of Zoomtown, the layout. It is dimensionally accurate in that the ratio between pixels and inches is very proportional and as precise as you can make it. The interesting thing is, as you can see, there's 32 destinations, and each destination would have 31 choices to go to because it occupies one of the destinations. And that equals 992 potential routes just to cover the basics. Now, what do I mean by that? As you can imagine, if I'm on any one of these parking spaces and I want to get to this destination, well, I could say back out, go down this road this way, go this way, go this way, and go into that parking spot. That would be the most efficient way. But I could also go this way, this way, this way, and this way, and this way. And now I've got two ways to get to the same destination. And now this thing can snowball from 992 routes up to probably, I'm going to guess, tens of thousands. I haven't done the math. I don't even want to. I don't even want to consider it. But this is part of what has to happen in the coming weeks and months, is to come up and develop all of these routes. Now, as you can imagine, that's an awful lot of work. And that'll be part of some of the questions I'll have for you at the end of this video. But in the meantime, what I'd like to do next is we'll go over to Zoomtown, and I will be showing you how things operate between the Zoomy, the scheduler, how the scheduler software operates. And from there, we can take this whole project into our next level. So I'll see you over there. Well, it's been an interesting week since I filmed the beginning and end of this story. What had happened on this computer where we're working right now, this is the control center for the Zoomtown experiment. Most of what we're going to be focusing on in the next few minutes has to do with the scheduler. That's a computer, Raspberry Pi Model 4, that runs Pygame add-on for the Python language, and that's what it'll be running to control the experiment. Well, apparently Pygame, and I already know it, I can see it, when the program is running, it's sucking an additional 30% resources. So when I tried to screen capture like I normally do, over on the other computer, which is a Windows-based computer, unbeknownst to me, it was drawing much more resources than the Raspberry Pi 4 could keep up with. So nothing I was recording on the screen was keeping up with any explanations. In fact, it would just literally freeze up and then free itself up a couple minutes later and then try to catch up. It was a disaster. So I tried everything I could with what I had available to me last week, and nothing worked. So I went shopping on Amazon, where it seems like everything you need is there, and I found a couple of instruments or a couple of devices that solved this problem. So a week and about $300 later, I can now finish the mid portion of this video for today. Just so you get an idea, I'll put up a graphic. This is now the scheduler's, we'll call it desktop. The device on the left next to the red microphone, just to the right of that, is the screen capture device. It's literally capturing the data coming out of the Raspberry Pi 4 via its HDMI cable on the spare channel. Raspberry Pi 4 has 2 video outs. So getting back to what I wanted to explain today, as we're moving into phase 3, a lot of things are going to now be over here on the actual Zoomtown, which is what I'm looking at forward here. And overhead, you'll see just the end 25% of it on this other camera angle. And that's all I have with the marker tape on it for experimenting right now, and I'm about to put the rest of the marker tape on because it is working extremely good. Hopefully I didn't just jinx myself, as are the magnetic markers that I'm using in the system. So what I want to do today is just explain to you how this system works with the scheduler software and the Raspberry Pi PICO control software for the zooming. So let's start here on the desktop that I'm now capturing with my new device. This is the scheduler layout and software. I had to kind of do it this way because of what we're doing. I figured that making it all a graphical user interface would be smarter. Now at this point, this scheduler software, I recently changed over from just being the scheduler, which would route all the zoomies from one place to another at random times and to random places. And that would just simply run. So that was the original intent for it. But I've since added in the capability for programming. And if we look at the screen here, we can see this is how programming would be done. I would be in the programming mode, and that gets switched with this toggle here. All of these down here are the zoomy icons, and right now they're off the layout, and that's fine for what we're doing with programming. These are the controls I have to create a program path or a trip plan, and to do it is quite simple. I'm going to say I'm starting at destination 32 here. I'm going up road 21. That'll connect with road 0, which will connect with road 18, and we'll take it and end the trip at destination 28. If we look over here on the right, I'm starting at destination 32, end at destination 28. All these destinations are parking spaces on the actual layout. This is a list of the roads used in order. Now from that, if I click Process Trip Plan, it will go through, perform all the calculations, etc., and get the trip plan made to go along that path. And it has to take into an awful lot of calculations. The math on it's mostly just simple math, adding and subtracting and so forth. But what we have to do is also, in this trip plan creation, find and reference all the position-related magnets, the preset magnets as I've been calling them. And it has to get all the headings set right, the global position. Global position means on the actual city layout, there is one origin. And it's when you're looking at it in the normal orientation, not like I have it set up now, the normal origin point would be in the upper left corner of the city Zoomtown. So it would be way over there, and everything else is relative to that point. And that's how we will be communicating between the Zoomy control software it'll be at some location relative to that singular origin point, and maybe it needs to ask permissions to move. Well, that would be the coordinate system that we're working in. So kind of it's a bad thing, but it's a good thing. In this whole system, there's three different coordinate systems that we're working with. I'll go into detail on that in a later video. But that's what we've got here. So if I click the process, it outputs a list of the trip plan. We can simulate it, and this is a very crude simulation. You'll just see an icon for a Zoomy going along the path that I created. And then finally, I can save that path because we will program it, save it, so it only needs to be programmed once, and then it'll be saved on in one of the directories, and then I can call those trips up randomly and not have to recreate them every time. And then finally, if I just wanted to test it on the track right now, I can do that. Now the next thing I would do is click the button that says select Zoomy and run, and what that's going to do in the future will allow me to select which Zoomy I want to follow along this trip plan. In this case, I've only got one Zoomy in the whole system, so I've bypassed one part of that next step. I'm going to click it, and what it should do, we should see it listing by here. It's over on Thani running on another system over there, which is connected via the umbilical cord to the Zoomy on our layout. Now it sent the data there, and an LED turned red on it, indicating that it's got instructions and it's holding until we give it the cycle start button. And that's the button located on top of my control panel. So we'll hit cycle start, and it will execute that particular trip. And I got to keep an eye on the cord. It wants to run that over at times. Okay, and that just tested and verified that particular trip plan. Now if I save it in there, I can recall that at any time and have any Zoomy follow that exact same trip plan, starting from that location and ending at that location. Now just so we can see it go one more time, I'm going to do a reset. Right now we're in destination 27. We'll go down to road 11 via 18, come up road 21, and go right back into the last parking space where we started from. So we'll process that. I'll simulate it, make sure I did everything right. That looks good. And now I will send it to the Zoomy. Went through to the Zoomy. I'll hit cycle start on my control panel, and it should take off running. And again, I got to watch the cord. Now this really marks a new beginning and a new phase. Up until this point, all the testing I've done, the trip plans were hand-coded and within the Zoomy control software. And as you're seeing right now, we're getting that data from the scheduler, passing it through Wi-Fi via MQTT to the Zoomy, and then from there we're executing it within the Zoomy. Now during that process, and a lot of this has to be coded yet, what I will be doing as the Zoomy travels along, it will be updating its current global position and transmitting that back to the scheduler, and then I could be updating the position of the icon for that particular Zoomy. So it'll be all animated when I finally get that part of it done yet. So that's what we've got going on now. And as you can imagine, there's been a tremendous amount of work in the last, realistically, we'll say month for me to keep up with video production and at the same time concurrently developing and refining the Zoomie control software and getting the scheduler software all changed around to fit the way I want it to work today, because it's worlds different than it used to be. I'll show you one more thing on here before we will wrap this up. I'm going to go back to the mode of the scheduler mode. And if I wanted to run the experiment, meaning it'll start running random paths for each of the Zoomies, I would click the Wake Up Zoomtown button, and it's in an idle state, meaning that it's already planned out a bunch of courses for the different Zoomies. I would hit Cycle Start on my panel, and the experiment would begin and continue to run, at which point I would have a way of interrupting it and terminating it. None of that's coded yet. But what is coded is something that's going to be very important. There will be times when a Zoomie breaks, so I need to take it out of service. So we don't want to be sending that traffic instructions or driving instructions. So every Zoomie right now is down here. It's not on the layout for Zoomtown itself. So if I'm setting up for an experiment, I need to get all the Zoomies up on the layout, or which ones I'm using. So for example, if I say I want Zoomie 1 on destination 1, I'll place it there. So that was the selected Zoomie on the right of the screen, and selected the destination by clicking the button in the driveway. And that puts that icon there. So now I would physically place Zoomie number 1 at that location. And that's going to be very critical. And by the way, just a quick side note, and I'll probably bring this up again. Steve Woodgate was the fellow that suggested I work with QR codes for helping with localization and all that. This would be a perfect example of how good this system could be if I wanted to take it to the next level, and hopefully we will. What I would do is have a QR code in the side of the driveway there, that the camera looking down could see that QR code and automatically place it here on the layout. That would be awesome. So that's kind of, as this thing progresses along, we'll be getting into that. Thanks again, Steve. That was an awesome suggestion. But we can go ahead and store any Zoomie into any destination by placing it. And then if I want to store a Zoomie, I would say store, and then it would put it back down into the storage area. So that is how this whole system will work. Now, there is a lot of code I've got to write yet, and there's a tremendous amount of work that's going to go into getting the rest of this system up and running. Just to give you an idea, I'm estimating it'll probably be about 30 to 40 hours of work to get the rest of the marker tape and the magnets put on the layout. So that's just to do that, and then all my extra coding and all that. At this point, as a quick reminder, Zoomie control software is probably in that 90 to 95% complete range. The scheduler software is probably closer to about the 60 or 70% range complete, and I kind of made a lot of progress on that this past week. My normal job didn't have high demands on my time, so I was able to put some effort into it and bring us a little bit forward. So with that, I think we can wrap up this part of it, and now we'll go back to the other part of the story, which I filmed last week, which will close out this video. Now, this is where I need help from you guys. I need to understand what you want to see out of this experiment. Most of you have been with me since the beginning, 42 episodes, 42 weeks. And what's going to happen now, the focus has got to change, and I could go through a tremendous amount of time trying to explain all of the code for the scheduler software. how to set up and configure MQTT and all of that sort of thing. And I think I'm going to end up getting way off track with a lot of that and take the focus away from the experiment and the Zoomy and what we're trying to get it to do. However, you guys are the boss in this game. I want to deliver to you what you want to see. My preference at this point is we start looking at this more from a top-level view, what we're doing, and with the exception of anything with the Zoomy specific, I don't have to go into deep detail of the scheduler software. I need your input on that. How do you want me to handle that? Talked with a few of you already privately about this, and I'm very appreciative of your feedback, and that is the way I'm planning to go, but I figured I'd throw it back out there at this crucial time. Another aspect I very well may need help with. The reason why I kind of kept emphasizing the number of trip plans that have to be created, about 1,000 of them. And I mean, it's not a difficult task, but it takes time. And if I can get everything more stable, what I was kind of thinking, if I get the scheduler software stable, and right now it's running on a Raspberry Pi, I could also make it run on a Windows computer. In fact, I was doing some of the development up in my office and for quite a while, and then kind of just had to change a few things to get it back over. But in any case, you would need Raspberry Pi, or you would need a Raspberry Pi. You would need Python 3 installed on the computer. You don't need the Raspberry Pi. What you need is Python 3 and Pygame installed on either a Windows computer or on a Raspberry Pi. And then I could send you the package of everything that would run in the Python code, and hopefully you could say I would assign you destination number 10. You program all the paths for that one, and then you send those back to me. They're tiny little files, so it'd be very easy to do in that regard. I'm just throwing it out there, and if you want to contribute on that, definitely respond in this thread, because that'll help me keep track of where everything is. But if you respond there and it looks like we're going to go forward, I'll have you go to our website and use the contact form there, and then we'll probably take it off and just communicate via regular email at that point. But those are two really important things. I need to know what you want to see as this progresses forward, and I'm looking for some help if you got time to help on it. But the biggest if of that is if I can get the software stable enough where somebody outside of the confines I'm in right here can keep it running and be able to program the paths. Just let me know in the comments below. In the meantime, as you can see, I got an awful lot of programming to do, and I got to get right back into it so I can come up with some content for next week. Thanks so much for being a part of the show, part of the community, and thanks again for subscribing and doing all the things that you've been doing to help this channel along. I look forward to seeing you next week.